Hello. Today we are going to continue on chapter 6, function of random variable. Especially we are going to study summation of two random variables. So we are going to find how to calculate the distribution of the summation. So first of all, when we are summing up two random variable x and y, we will get another random variable. We have many applications like this. For example, we have a system where, for example, we have a system like this, that there is a light here. This is a electrical system. For example, this is a light. If this light, for example, malfunction, is not working at some time, and then we will replace with another light, and this light is like in a standby condition. Here we have pointed out this standby connection. So this configuration is called standby when one component is stop functioning, then another component replace this component. So this configuration is called standby configuration. So anyway, when we are, for example, u is a random variable which is the summation of another random variables, and these two are independent x and y. In that case, we can derive the CDF of the u like this. You can see u is less than small u, and which it can be rewritten by x plus y less than u, and so on. And if we continue like this, you can also see some limit how we place the limit here. We know whenever we are going to do integration, we have to put a limit here. Look at the limit. Here the limit is, for example, x. For x, if we do the integration of x first, we have to put limit like this, minus infinity to u minus y. Why u minus y? Because x, there is a limitation here, x plus y is equal to u. So x should be u minus y. That is the highest limit of x. So we cannot put just minus infinite here. However, for the case of y, we can the y can range up to plus infinite. Here we put minus infinite because the x can be minus infinite, so y can also be minus infinite. So anyway, and this limit of the integration is put in the picture like this, and that we know x plus y is equal to u, and so we have two variables x and y, and it follows a straight line like this. Okay, so whatever the area beside this line, the left side and down side, the whole area should be integrated. Anyway, I think you don't need to memorize this derivation. After putting this limit, we will find something like this: fx u minus y and fy. It will be something like this, and if we differentiate the CDF, we will get another PDF, small fu, which will be look like this one. And this formula, this mathematical formula, is very familiar to you, all of you, because we call it convolution integral, where one function is y, another function is written in terms of u minus y. So this particular combination of integral is called convolution integral, and we in shorthand we write like this: fx u star then fy u. So I think all of you can recall you did this in convolution in signals and system, when we have to find the impulse response of a system in time domain. You need to do some convolution like this, right? So let's move on. Let's see an example. From now on, I am going to use my handwritten slides. Here we can see another example of this summation of two random variable, which is, for example, you have attended we have two class tests marked, and both of class tests are equally distributed between 0 to 10. So we have a uniform distribution, both of them 0 to 10. But if we sum these two class tests, CT1 and CT2, in that case the marks will be distributed between 0 to 20, right? But the question is, will it be look like uniform? Do you think it will follow another uniform distribution? The answer is that even though it feels like that, it will also be another uniform distribution. Basically it will not be. It will be look like some triangular wave. Okay, so we will find that out. So basically this is wrong. So we will find this out. So let's see an example 6.3. This is the example from the book. So we have two uniform distribution, fx and fy, both are same, which is distributed between 0 to 4. So the constant should be 1 by 4, so that the total probability of this variable should be 1 equal to 1. And we are going to find out how the distribution of S look like, where S is equal to x plus y. Now if we follow the we have to find the distribution of S using the convolution integral, and we will follow the exact procedure which we have applied in signal and system. And what is the procedure? The procedure is that we need to, first of all, we have to draw the fy here, and we have to draw the fx s minus y. So before finding out how the function s minus y look like, we have to plot s plus y. So the fx s plus y will look like something like this. Whenever you plus something, for example, we have here plus s. So plus s means the function, the plot will shift it towards left. If we have something y minus s, it should be shifted right side. It should start something like here, plus s. And for s y plus s, it should be shifted left towards left direction. So it will start from minus s and it will end at 4 minus s, whereas the original function was 0 to 4. This function will range from minus s to 4 minus s. So this is s plus y. Now after shifting the function by plus s, we will now replace this plus y with minus y. That is called inversion. So during the inversion, what will happen? This function will be just reflexed, or it will be just it will rotate, it will inverse around the y-axis. So what will happen? This 4 minus s will be something like s minus 4 on the left side. That means this point will appear here, the other side, and this minus s will appear on the right side, which will appear as s. Okay, so simply this is like a mirroring. When we see something in mirror, it gets it swap two sides. The right side become left side become right side, etc. Right? So the function this fx s plus y, if we convert it to s minus y, that means we are replacing plus y with minus y. What will happen? What will happen is this point will become a point in the left side. That means this is minus 4 minus s, which is same as minus 4. So s minus y will look like something like this, s minus 4 to s. Okay, and the original fy, we have changes the function the fx from fxy into fxs minus y, and we keep the original function fy same as original in our equation fyy, okay, which is from 0 to 4. Now we are going to multiply these two functions, but before multiplying these two functions, we have to understand that depending on the value of s, these two the multiplication will result in different values. For example, if s is less than 0, that means this function fx function is totally on the left side of the y-axis, right? So what will happen in that case? Fx and fy will have no overlapping between them. That means if s is less than 0, the multiplication will be 0. Why? Because there is no overlapping between fx, which will be totally on the left side, and fy, which is totally on the right side, starting from origin, right? So if there is no overlapping between two functions, it will be 0. So we write it. We have written down that part here, which is mentioned as other range. So another case will happen when the s is in between 0 to 4. When s is in between 0 to 4, there should be some partial overlap, right? So we have written down. So there is two conditions here we are going to merge. One is s is greater than 0, and another is s is less than 4. So these two condition is written down here. S is ranging from 0 to 4. So for this range, we are multiplying these two functions, each of them containing a value of 1 by 4. So 1 by 4 into 1 by 4, so which is 1 by 16, and we are going to integrate from the range 0 to s. So to find the convolution, we have to look at we have to focus on two different things. One is the range of s for which this multiplication is a non-zero, and another thing is that we have to integrate from 0 to s, because only within this range these two function has a non-zero product. Okay, if we look at less than 0, there is no fy, so fx into fy is totally, multiplication is totally 0 in this range. And similarly, after in between s and 4, there is no fx, so fx into fy is, the multiplication or product is 0 here. So we are going to integrate only in between 0 to 4. So there is two parts. One is the limit of integration, which is valid for 0 to s, because this is the part where two function is overlapping. Another thing is that for which range of s this is the condition. We have already talked about it, that for the range of s equal s for the range from 0 to 4, the value of s is valid, because only for this value of s this situation will arrive. Okay, this integral will be valid. So in summary, we are going to find the convolution for this range we using these two limit, and what is the value if we integrate this 0 to s, and there is nothing here, just 1. So if we integrate that, we will find y, and we put the limit s minus 0, which will be s, and finally the result will be s divided by 16. So this value of integration is only valid for this range of s. Okay, next. In the next case, this function will move further, and as will cross the boundary of 4. That means this s minus 4 point will be in between 0 to 4. Okay, so here we have two conditions. One is s minus 4 is less than 4, another is s is greater than 4. Okay, so using these two combination we will find a range of s which is s is less than 8, and here we can directly see s is greater than 4. So this is the new range of s for which this situation will arrive, and for this situation the valid range of integration is from s minus 4 to 4. So we have written down this integration here, and this integration is only valid for this range, and using this integration we can find something like this, 8 minus s divided by 16. Okay, so this is our answer, final answer of convolution. For this range it is s divided by 16, and for this range it is 8 minus s divided by 16, and for other range it is 0. So how does this overall function looks like? It looks like exactly a triangle. So it is 0 up to the origin, and then it will increase, and then it will decrease, and then again it will be flattened. So it's like a triangular function. It's not like the original uniform distribution. So we can see that the summation of two random variable is not like individual random variable. It's a different. It's like a triangle in this case. So I will request all of you to pause the video here and to find to practice another example, which is, for example, a class test, two class tests, a class test mark and a midterm mark. A cluster test mark is uniformly distributed between 0 to 20, and a midterm mark is uniformly distributed between 0 to 30. Okay, so try to find the distribution of summation of these two variables. So this is x, this is y. I hope you can do it. Okay, So if you finish this example, we will move to next one more example from the book. Here we will the question is like this. The time between two snowstorm is following an exponential random variable. We are talking about time. So between two random, so we have a storm right now. The storm is over. Now the next storm will come after a time x, and this x is following an exponential random variable. Now the question is, what is the period of time till second storm? So because the question mentioned second storm, it means we have to wait for first storm and then we have to wait for second storm. So it is the time of two storm, first storm, and then from first to second there is another time which is y. For example, first storm time is x, and from first storm to second storm the time is y. So there are two random variables and we are going to sum them up, which is u. So now both x and y are following this distribution. Okay, so we will now see how it will look like. So we have to follow the same convolution integral. So we will fix one fx and we will vary another one. We will try to redraw the function fyu minus x. So how the u minus x look like? U minus x will look like this way. You can practice it the similar way. At first you will practice u plus x. U plus x will look like this one. It will be something like left shifted, and then u plus x should be rewritten as u minus x. So it will swap the axis, so it will look like the opposite. So in this case the product of these two functions is valid from 0 to u, only 0 to u. We can see this function is ranging up to the infinite, and this function is also ranging up to the minus infinite, right? So the valid range of integration is 0 to u. So in this case only non-zero product is coming for a condition u greater than 0. If u is greater than 0, only then we can find a non-overlapping area, right? Overlapping area means it will not be a 0. So for u less than 0, if u is less than 0, that means if this fy is somewhere here on the left side, then there will be no product. The product will be 0, and eventually the integration will be 0. So this integration is only having a non-zero value for u greater than 0. And for that we will simply write fx, which is lambda into e to the power minus lambda x, and fy u minus lambda, which will be lambda e to the power minus lambda. You can see we are not writing x here, we are writing u minus x here, right? We are replacing x with u minus x from here to here, right? And we also note that you should also note that the limit is from 0 to u, because only in between this limit these two functions are overlapping. We will have a non-zero product. So if we continue, we can see that our integration variable is x. You can actually, this convolution integral can be written in terms of dx, it can be written in terms of dy, or it can be written in terms of any variable. It doesn't matter. Only matter is that in one function it should appear x, and another function it should appear u minus x. That's it. If you write down y, you can just replace the x with y. It's fine. Anyway, here the integration variable x, so we can take this term lambda square e to the lambda u out of the integration, and we can write this as a u. So the final answer is this one, which is valid for u greater than 0, and other than for u less than 0 it is 0. Similarly, I hope you can practice fx these two example, which is also given in the book. So if you cannot do it yourself, you can look at the book, no problem, but try to do it by yourself. Here what is the difference is fx is following exponential, but fy is not. Fy, there is an additional y variable here, and for 6.7 it is both are following exponential, but the time constant or the average time lambda or mu is different, right? So here the constant is lambda, here the constant is mu. So try to solve these two problem based on this convolution problem. Answer is given here and here, and also it is the math is already worked out in the book, so try to do it. So today you can pause this here and try to practice this, and after this we will move to a little bit more. Today I am going to shorten the lecture. I will finish right here, the moment of sum of random variables. If we have two random variables x and y, and we are interested directly for the expected value or average value of s, then we can find it directly from x, expected value of x, plus directly expected value of y. If we know individually what is the average value of x and what is the average value of y, we can find directly the expected value of s from the summation of these two. Okay, so and for the variance, we can find the variance using this formula. We can sum up these two variance, individual variance, and then we have to add additionally 2 into covariance of xy. If we see that these xy are independent, then this covariance will become 0, and it will be simply sigma x square plus sigma y square. Okay, I'm not going through the derivation, just we're going to use these two formula. Okay, for usually x and y are independent, and in that case the variance will follow this formula. Okay, in next class we are stopping here for today. The next class will be based on sum of discrete random variable. We will continue from here. Thank you all.